Hello, class ninth. So we have been studying chapter number 12, that is sound. Yes. So in previous class we studied that what is sound and sound travel through the medium. Yes, sound need a medium to travel. So today we will prove this topic that sound needs a medium, and we studied what is sound. Yes, sound is produced due to the vibration of the object. Sound is a form of energy. Vibration is actually the rapid to and fro motion of an object. Yes, and the sound produced by vibrating object travel through a medium to a listener. Yes, the medium can be solid, liquid, gas, any. Yes, when an object vibrate, the particles around the medium vibrate. The particle in contact with the vibrating object is first displaced from its equilibrium position. It then exert a force on the adjacent particle, and the adjacent particle is displaced from its position of rest. Yes, after displacing the adjacent particle, the first particle comes back to its original position. Yes, this process repeats in the medium till the sound reaches the ear. Yes, and mm, so and we also studied what is compression and reflection, rarefaction. Yes, air is, we know that air is the most common medium for through which sound transfer. So travel, when a vibrating object moves forward, then it pushes and compresses the air in front of it, so forming a high pressure region, that is called compression. And the compression moves away from the vibrating object. Okay, and when the vibrating object moves backward, it forms a region of low pressure, that is called rarefaction. Yes, we studied all these point. Now next is sound needs a medium. Yes, so as you can see on the screen, and really sound need a medium or not, let's see. So sound actually is a mechanical wave. Yes, sound is actually a mechanical wave, and I have already told you sound is actually a mechanical wave, because since sound waves are actually produced due to the vibration of particle. Yes, of the medium, due to the vibration of particle of the medium. So sound waves are called mechanical wave. Okay, and get so sound is a mechanical wave and needs a medium for the propagation. Yes, for traveling. Sound travel through solid or liquid or gas, from all. Okay, sound does not travel in vacuum. Yes, remember this point. Sound does not travel in vacuum. Means vacuum means without air. Yes, if there is no air, sound will not travel. So as you can see in the activity, so you will have to take electric bell and you will have to suspend the bell in airtight bell jar. Yes, you have to take a bell jar. Okay, you can take a jar in which you will suspend the electric bell. Okay, and you will connect the bell jar to a vacuum pump. Yes, you will fit at the bottom a vacuum pump. So with the help of vacuum pump, all the air will get passed. Okay, if the switch is pressed, when we will press the switch, then we can hear the sound of the bell. Yes, we can hear the sound. But if the air is pumped out, yes, if we threw out all the air through the vacuum pump, then what will happen? When you will switch on again, then the in the bell jar the electric bell will not ring. Why? Because there is no air, because the air is a medium and there is no air, no medium present. That's why we cannot hear the sound of the bell. This shows that sound need a medium to travel, and sound cannot travel in vacuum. Yes, I hope you understood. So, or you can take any bell jar and you can put a ring also. You can put a watch also. Okay, and you can attach it with a vacuum pump, and when the when the watch will ring, it will not produce sound if all the air is pumped out. Okay, I hope you understood. Now let's study what are longitudinal waves. Okay, let's move on the next point. So again, the sound waves are actually longitudinal waves. Yes, sound wave can be longitudinal. Okay, we will also discuss some characteristic related to sound wave. Okay, don't worry. So, you let's do a work to prove it. Okay, so stretch a slinky and push and sound propagate in a medium as a series of compression and rarefaction, or you can take a prong, and when you will strike it, it will produce the sound and sound will propagate, yes, in a series of compression and rarefaction, as you can see on the screen. And we know what is compression and rarefaction. The lines which are too near, which are showing the compression, and the lines which are very far, they are showing the rarefaction. So in these waves, the particle move back and forth. Yes, we already know that particle moves to and fro, particle move backward, forward, forth, parallel to the direction and parallel to the direction of propagation of the disturbance. Yes, particles move forth and back. Then they will be the parallel to the direction of propagation of disturbance. Yes, parallel, they will be parallel to the direction of propagation of the disturbance. Yes, and such waves are called longitudinal waves. Yes, so longitudinal waves are actually those waves which goes in the parallel direction, yes, of propagation of disturbance. Okay. There is another kind of wave also. Yes, there is another kind of wave also which are called transverse waves. So in these waves, the particles oscillate up and down. Yes, up and down, up and down, up and down. So perpendicular to the propagation of direction of disturbance. Yes, they will be perpendicular to the direction of disturbance. It alternately all one end. If you mark a dot on slinky, the dot moves back and forth. Or if you mark a dot on a tongue, if you mark a dot on a turning fork, then the dot will also move alternatively. Yes, the dot will move back and forth parallel to the direction of propagation of the disturbance. Okay, I hope you understood. So okay, now let's see some characteristic of sound waves. Yes, I have written some characteristic of sound wave. So characteristic number one, that sound wave can be described by its frequency, amplitude and speed. Yes, sound waves is actually described by frequency, amplitude and speed. Yes, FS. Okay, sound wave can be described by its frequency, amplitude and speed. Okay. Point number two, sound can be graphically represented as a wave. Yes, sound wave is actually graphically represented. A sound wave graphically represented as a wave. Okay, and there is a changes in the density and pressure as a sound move in a medium. Yes, there is changes in the density and pressure as sound moves in a medium. Yes, density and pressure change when the sound waves move in a medium. Yes, when the sound moves. So and it can be represented graphically also. Okay, it depend upon frequency, amplitude and speed. Well, we will also study about frequency, amplitude and speed, don't worry. Point number three, compression are the region of high pressure and density where the particles are crowded and are represented by upper portion of the curve called crest. Yes. What is crest? Curve. Crest is the upper portion of the curve. Yes. So because the sound waves are represented by lines which look like a mountain. So the upper portion of is called crest. So compression are the region of high pressure and density, so where the particle are crowded, so that area is actually a crest. And rarefaction are the region of low pressure. Yes, the bottom area is actually the represent the rarefaction, okay, and the lower portion of the curve is called trough, T-R-O-U-G-H. So rarefaction are the region of low pressure and density where the particles are were spread out and represented by the lower portion of the curve called trough. Okay, and next point is the distance between the consecutive compression and two consecutive compression means two crest and two trough is called wavelength. Yes, the distance between two crest and two trough is called wavelength. Okay, so or you can say the distance between consecutive compression and consecutive trough. Okay, um, well, wavelength is denoted by a Greek symbol, Greek letter which is called lambda, means inverted y. Okay, and its SI unit is meter. Yes, what is wavelength? The distance between two crest and two trough is called wavelength. Okay, it is represented by lambda. Okay, so its SI unit is meter. Okay. Yes, and what is crest? Crest is the upper portion of the curve, and what is trough? Lower portion of the curve. I hope you understood. And sound wave always described by to describe need, frequency, amplitude, and speed. Okay. Now let's move on the next point. Okay, so now let's talk about the time period. Yes. So what is actually time period? So time period is actually time taken. Okay. So the time taken for the change in density of the medium from a maximum value to minimum value and again to the maximum value is the time period of the sound wave. Yes, what is sound wave? What is time period of sound wave? The time taken to change in the density. Yes, to change in the density from maximum value to minimum value and again to maximum value. Yes, maximum value to minimum value and again maximum value, that is actually called time period, or you can say the time taken to complete one oscillation. Yes, time taken to complete one oscillation in the density of the medium is called time period. Yes, time taken to complete one oscillation. Oscillation means vibration. Okay, and time period is always represented by capital T. Okay, and its SI unit is S, second. Frequency and time are represented as follow. You can see T is equal to 1 upon V. V is actually a frequency, and if we change then the frequency form, what is the formula of frequency? V is equal to 1 upon T. What is the formula of time period? T is equal to 1 upon V. Okay, so as you can see, the high frequency and low frequency wave. Yes, high frequency wave have more waves and low frequency have less waves. Okay, and if the waves are less, then frequency will be less and the sound will also be less. Okay, if the frequency are more, then the waves will be more and sound will be more. Okay, so in high frequency wave there are many oscillation. So and in the low frequency wave, low oscillation. Yes, less oscillation. Okay, I hope you understood. So time taken for one complete oscillation in the density of the medium is called time period, or you can say the time taken from change in the density of the medium from maximum value to low minimum again maximum. That is okay. I hope you understood. Uh, Now, kids, let's talk about the amplitude. Yes, amplitude or amplitude. Okay, you can say. So let's move on the next point. So, with amplitude of sound wave. So the magnitude of maximum disturbance in the medium on the either side of the mean value is called amplitude of sound wave. Yes. So what is amplitude? The maximum sorry, the maximum uh, the magnitude of maximum disturbance, yes, the magnitude of maximum disturbance, yes, the magnitude of maximum disturbance in the medium on either side of the mean value is called amplitude of the sound wave, or you can say the amplitude of sound wave is the height of the crest or trough. Yes, if we are taking the height of crest means it is maximum amplitude, and if we are taking the height of trough then it will be minimum amplitude, and it is represented by a capital letter A, and the SI unit of it will be same as the density or pressure. Yes, SI unit will be same, and you know what is the unit of density. Yes, can you tell me? Kilogram per meter cube. Yes, that will be the same unit. Okay, or you know pressure unit already you know. So amplitude is actually the distance, height of the crest or height of the trough. Okay, I hope you understood about the right. So, or you can say the wavelength is the actually the distance between the crest of two waves, crest of two waves. Yes, uh, that are next to each other. So the amplitude is high at the crest. Okay, I hope you understood the meaning. So as you can see in the picture also, the crest is actually the actually the crest is the height from the mean position. Okay, and the same with the trough. You already know about it because you already studied in the 8th class. Yes. Now let's move on the next point. So kids, what is pitch and loudness? Yes, the pitch of the sound means what? Pitch actually tells that the sound is flat or shrill. Yes, it tells that the sound is either flat or shrill. Yes, so the pitch of the sound depend upon the frequency of the vibration. Yes, pitch of the sound depend upon the frequency of the vibration. Yes, so how? Because if the frequency is high then the sound will be of high pitch. Yes, okay, and if the frequency is low then sound will be low pitch. Yes, if the frequency is high then sound has the high pitch, which it means the sound will be shrill, it means the sound will be shrill. But if the pitch is low then the sound will also be if the pitch is low it means frequency is low. Yes, so the sound will be not shrill, sound will not you know why is the sound of girls shrill? Mosquito sound is also shrill. And because the frequency of frequency is very high, that's why. Okay, that's why the sound of girls little bit soft, and our sound, the sound of men boys is not soft because our frequency of the sound is low, so pitch is also low. That is the reason behind it. Okay, I hope you understood. So now you know that why is the sound of boys loud, because our sound frequency is low. Yes, understood. Now let's move on the next point. Okay, and one more point you need to remember that loudness of the sound depend upon the amplitude. Yes, loudness of the sound actually depend upon the amplitude. Yes, okay, amplitude of the vibration. Yes, okay, if the amplitude is bigger then sound is loud. Yes, if the amplitude is smaller then sound is soft. Yes, it means what? The amplitude of girls voice is smaller, that's why their sound is soft. Yes, and amplitude of boys is more, That's why our sound is loud. Yes, and you already know what is the meaning of amplitude. Yes, the magnitude of maximum disturbance in the medium. Yes, the magnitude of maximum disturbance in the medium, or you can say the amplitude of the sound wave is the high at the crust. Yes, the height from the mean position to the crust, or the height from mean position to the trough, is called amplitude. Mm, it is represented by capital letter A. Yes, and uh, loudness is actually directly proportional to the square of amplitude. Yes, loudness is actually directly proportional to the square of amplitude. Means if the amplitude is twice, then loudness will become it's double. Okay, I hope you understood. Now let's move on the next point. Okay, now let's talk about the speed of sound. Yes, what is the speed of sound? So, speed of the sound is actually different in different medium. Yes, in solid it is different, in liquid it is different, in gas it is different. Yes, for your information, let me tell you that in the gas, the sound of in the gaseous medium, the sound of speed is very less, means least is the speed in gas, and in the liquid the speed of sound will be medium. Yes, but in the solid it is more. Yes, it means what? The sound travel very fast in solid in comparison to liquid. In liquid the sound travel fast mm, in comparison to gas, but in gas the sound travel very slow. Okay, okay, so in solid the sound speed is fastest, in liquid fast, but in gas slowest. Okay, so the speed of sound also depend on the temperature of the medium. Yes, it also depend upon the temperature. Yes, if the temperature will increase, then the speed of sound will also increase. Yes, and what is the relationship between speed, frequency and wavelength? Yes, the relationship between speed, frequency and wavelength is speed is equal to wavelength multiplied by frequency. Yes, speed, if the speed is denoted by v and wavelength is denoted by lambda, then frequency will be denoted by capital V. So the formula will become small v is equal to lambda into capital V. Okay, so the formula is speed is equal to wavelength into frequency. Yes, this is the formula of speed, wavelength into frequency. Yes, okay, so if the wavelength and frequency is increasing, then speed will also increase. Yes, speed will also increase. I hope you understood. Now let's move on the next point. Okay, it's time to ask question from you. Question number one: what will be the speed of sound in different medium? Yes, so the speed of sound is more in solid, less in liquid, and least in gas. Yes, remember the speed of sound is different in different media. The speed of sound is more in solid, less in liquid, and least in gas. The speed of sound also depend upon the temperature of the medium. Yes, if the temperature of the medium is more, then the speed of sound will be more. Question number two: write the relationship between speed, wavelength, and frequency. Yes, what is the relation between speed, frequency, and wavelength? Yes, actually, speed is equal to wavelength into frequency. Yes, if the wavelength or frequency is increased, then speed also increase. This is the relation between speed, wavelength, and frequency. Yes, remember, speed is equal to wavelength into frequency. Question number three: define amplitude. What is the relation between amplitude and loudness? Yes, what is amplitude? Amplitude, the amplitude of a sound wave is actually the height of crest or height of trough. It is represented by letter A. Yes, and its SI unit is same as the unit of density or pressure. And one more definition of amplitude is the magnitude of maximum disturbance, the magnitude of maximum disturbance in the medium on either side of mean value. Yes, on either side of mean value the magnitude of maximum disturbance. And what is the relation between loudness and amplitude? Well, the loudness of sound depend upon the amplitude of the vibration. Yes, it depend upon the amplitude of the vibration. Yes, loudness is directly proportional to the square of the amplitude. If the amplitude is twice, loudness will become fourth time. Yes, so I can say that if the amplitude is bigger, then sound will be loud, and if the amplitude is smaller, the sound will be soft. Okay. Question number 4. Prove that sound needs a medium. Write the characteristic of sound wave. Yes, what are the characteristic of sound wave? What are the characteristic of sound wave? Characteristic number 1. One is that sound wave can be described by frequency, amplitude and speed. Characteristic number 2. Characteristic number 2, sound can be graphically represented as a wave. There is a change in the density and pressure as sound wave move in a medium. Yes, there is always change can happen in the density and pressure when the sound moves in a medium. Okay. Characteristic number 3, compression are the region of high pressure and density where the particles are crowded and are represented by the upper portion of the curve called crest. Point number 4, rarefaction is the region of low pressure and density where the particles are spread out and represented by the lower portion of the curve called trough. The distance between two crest and two trough is called wavelength. It is represented by a Greek letter lambda, and its SI unit is meter. And sound waves are actually longitudinal wave, remember that. Okay, there is another kind of wave which are called transverse wave. Okay, in these waves the particle oscillate up down and perpendicular to the propagation of direction of disturbance. Yes, but longitudinal waves are those which actually whose particle actually moves back and forth. Okay. And how can I say that sound need a medium? Yes, sound need a medium. Without medium, sound cannot travel. Yes, sound does not travel in a vacuum. For example, you can suspend a electric bell. You can suspend an electric bell in air type bell jar and connect the bell jar to vacuum pump, and if the switch is pressed, then what will happen? Yes, what will you do? You will suspend the electric bell, okay, in a bell jar, tight bell jar, and connect the bell jar to a vacuum pump. If the switch is pressed, then we can hear the sound. But if all the air is pumped out through the vacuum pump, then we cannot hear the sound. This shows that sound needs a medium to travel, and sound cannot travel in vacuum. I hope you understood. Now we will meet in next class. Till then, bye bye.